Welcome. This is the APES Chapter 16 lecture on air pollution, climate change, and ozone depletion. Got a lot to get through here. So we see that we start with an investigation on melting ice in Greenland. Um, we're seeing the warming of the atmosphere. That's where we're going to start this climate change adventure. We're seeing a rise in the average temperature above the land and the sea, which is a huge problem when it comes to glaciers. If left unchecked, climate change will have a huge effect on global ecosystems. Greenland is the world's largest island, covered mostly by glaciers. Check out how much this could cause global sea levels to rise. 23 feet. Think about places that you've been on the beach where that would cause the road to be underwater, places where that would cause hotels to be underwater, and things along those lines. So, of course, the challenge is what can you do to address atmospheric warming, and we'll get to that, of course, later. Um, we need to first figure out what are the problems with air pollution, what types of things are causing issues. But before we do that, we need to look at what the atmosphere is, look at some of the layers and the levels of organization there. So the atmosphere is composed of several layers. You'll see a picture on the next slide. The layer directly above the surface is called the troposphere. That's what we live in. That's the air that we breathe. That's the troposphere. The layer above that is called the stratosphere, which contains the ozone layer. And if we look here, we've got the surface with the troposphere going up. The ozone layer lines the top of the troposphere, but it's found in the stratosphere. Um, Also note that there aren't specific like state lines type of things. The borders between these lines, between these layers, are fuzzy. Essentially, wherever you hit the ozone layer, that's where the troposphere stops and the stratosphere begins. Notice that we tend to see this same trend as we move through the mesosphere and the troposphere. And then the stratosphere and the thermosphere have similar trends. That's going to be important, not so much in this course, but if you continue on and you study like Earth space science, or you study, I had a geology course called Planets and Meteorites. If you study space at all, those phenomena are going to be important. Anyway, moving on to sources. Oh, I'm sorry. Moving on to air pollution. That's going to be anything that's in the atmosphere that's maybe not supposed to be, or at a level that it's not supposed to be. Um, there are several natural sources of air pollution. Things like volcanic eruptions are easy to see how that would cause air pollution. Wildfires, I think, make sense. If you've ever seen a dust storm or a sandstorm in the desert, you know that that can cause huge levels of air pollution. And then, of course, plants can release toxins. Animals can release toxins, things along those lines. And of course, we burn fossil fuels, so we throw off that that ratio. We need to make sure we can differentiate between primary and secondary pollutants. A primary pollutant is really bad as it is. Gets pumped out, maybe um, something that's going to deplete ozone, like an aerosol, something along those lines. Something like CO2 is a problem immediately. Secondary pollutants aren't a problem initially, but when a primary pollutant is processed and combined with something else, it becomes dangerous. If we look at this picture, I think this will help kind of clarify that. Over here is our list of primary pollutants. So things like sulfur, carbon monoxide, carbon dioxide, nitrates, things along those lines. Over here are the secondary pollutants, and most of these are going to be turned into acid rain or acid snow, acid deposition, something along those lines. They also can be processed in other ways to become dangerous. But again, a secondary air pollutant just has to be processed before it is dangerous. The major outdoor air pollutants are going to be carbon oxides, monoxide and dioxide, nitrogen oxides and nitric acid, sulfur dioxide and sulfur acids. Again, those are going to be converted to acid rain, acid deposition. Particulates are going to be anything that's suspended in the air. Most of the allergens that cause asthma and things along those lines, or exacerbate asthma, are caused or certainly made worse by particulates. Ozone is a major outdoor air pollutant. We'll look more about that in a second. And then volatile organic compounds. Those are really bad chemicals that we release. So things that either increase or reduce outdoor air pollution, settling, like particles settle. So like if a dust storm is stirred up, then uh, the dust can then settle. That'll reduce outdoor air pollution just by the particulates being smaller. Rain and snow cleans the air, pulls those toxins out of the air and deposits them into the hydrosphere or the lithosphere. Salty sea spray from the oceans, again, is going to purify. It's going to remove some of those toxins. Wind dilution and removal, chemical reactions in the atmosphere, all those things are going to reduce air pollution. Going to increase, these things are going to increase air pollution. Urban structures that block winds because it doesn't allow things to be dispersed or diffused. Hills and mountains, same deal. So if you're in a valley that has a major city, like Chattanooga, you've got a really good chance of building up these VOCs and causing issues like a temperature inversion or a thermal inversion. So smog, photochemical smog it's called light smog, dark smog. Industrial smog is going to be basically what is it made of? If it's made of sulfur, sulfuric acid, and particulates, that's what we see as the dark smog. China, India, Ukraine, Czech Republic, Bulgaria, and Poland are all examples of places that have those. And then photochemical smog is a mixture of stuff. Going to be more secondary pollutants for sure. That's what we see in LA and San Diego and some of those places where it shows up in the morning and then burns off in the afternoon. Again, what the difference between the two is going to be what they're made from. Respiratory system is going to offer some protection from air pollution. You've got all the air filtration systems that you have, but long exposure, or sometimes even acute exposure, like small scale intense exposure, can lead to breakdowns of those defenses. So acid deposition is what I often call acid rain, but it's wider than that. It might be acid snow, or it could be dry deposition where the acidic particles physically fall themselves. Um, Again, it's going to be acidic components that that either are emitted or can combine with water in the air and can be spread over a long distance. It's often called a regional pollutant because this is going to form over here and then be deposited somewhere in the nearby vicinity. It's not going to be deposited across the country. It's going to be deposited regionally. Lots of problem areas. You see the red is where there are current problem areas. Yellow is where it could extend, and then green is where it could extend. Could be a problem because the soil is really sensitive to acid. Yellow is there's air pollution there that could develop. Um, so notice that this air pollution or this acid deposition is a problem where there are major cities. Major cities here, major cities here, major cities here. So um, again, it's a regional problem. Our major cities in the U.S. are here, so the acid rain's not going to blow clear to Kansas. And there are no red dots there, even though we've got major cities there, because we've made gains in reducing volatile organic compounds that have been released into the atmosphere. So problems and solutions. Well, it's raining acid, so any plant that's going to be in the environment is going to be damaged by acid raining down on the organism itself. It's going to damage buildings. I can remember going to Gettysburg as a late elementary schooler and being amazed at all the monuments from Indiana being broken down. Well, that's because they use Indiana limestone to build the monuments at all the Civil War battlefields. So other places will use granite or other rocks, marble, and things like that, and those are not as porous. They're not as vulnerable to acid degradation. So, like Illinois statues look pristine, and Michigan statues look pristine, but the Indiana statues look like they've been melted, and it's just because of the acid rain that's in Pennsylvania that falls and melts the limestone. So our statues look like they're all melting and dissolving. Also going to contribute to human respiratory disease, leach toxic metals into the environment that get biomagnified in food webs. Think about invasive species there. Um, so a lot of negatives. Prevention is by far the best solution. If we could eliminate those pollutants from coal-fired power plants, or better yet, develop renewable energy technologies, a lot of this problem would go away. Indoor air pollution can be a huge issue in any country, but in less developed countries, indoor burning of wood or charcoal or dung or anything, coal, and open fires or poorly ventilated fires for warmth can cause huge problems. Same thing is true here. We also have lots of things given off by materials and furniture that are just in our homes. Uh, Check this out. 11 common indoor air pollutants are higher inside the U.S. buildings than outside of those buildings. So I've got a slide on the next slide, and it's going to show you some of those air pollutants. Air pollution inside cars and congested traffic can be almost 20 times higher than the outside. If you've ever been in a car with someone that's smoking cigarettes, you've experienced that. Here's a list of the indoor pollutants in modern homes, and you'll see a lot of these. It would make sense why there would be a lot more inside than outside. Things like chloroform that we find in water. Things like nitrogen oxides that we find in different household items. Particulates like pollen and things that build up in our fabrics, and asbestos that's in tiles and some ceiling tiles and things like that. So how can we reduce indoor air pollution? Well, don't use fires inside or ventilate them properly if you have a wood stove or a fireplace or something like that. Ban indoor smoking and increase air circulation in commercial buildings and homes. There's something called sick building syndrome, where like one of my previous schools had it. They called it the sludge, and just about every new teacher in their first 2 or 3 years got this respiratory infection, and the students all got this respiratory infection, and they found out that it was because the building had this bacteria that they had to treat and get rid of. So set stricter standards for emission from the products designed or made for indoor use. Um, Reduce our chemicals. Same thing here with natural ingredient cleaning products. Reduce the amount of chemicals we're using, and this pollution kind of takes care of itself. What about outdoor air pollution? Well, we can enact or we can enforce laws or standards that currently exist, or we can come up with new ones. Strengthen laws by increasing prevention, making it more expensive to pollute, making it more affordable to change and to be renewable and sustainable and things along those lines. Setting stricter regulations for airports. Airplanes are a huge source of air pollution. The amount of emissions that jet fuel produces is pretty high. And then using emissions trading, where you're doing a cap and trade. Cap and trade is a really big idea. It's essentially saying that I can pollute a certain amount. If I want to pollute more than that, I need to buy someone else's right to pollute. I can't buy extra pollution abilities. I can buy someone else's right to pollute. And the idea there is the amount of money that I'm paying to pollute should be used to remove that amount of carbon from the atmosphere. Maybe that means planting a forest with my pollution money. Maybe that means coming up with some innovative technology or something along those lines. But that money should go to removing my carbon pollution. So that's 16.1. I'll pick up with 16.2 in the next video.